Thank you, Jimmy, and thank you to the P&G Corps for allowing us to make a presentation about our project in the New Ireland Basin. I'm very grateful for your time today. Thank you for coming, and I hope you find this interesting. I'll be talking about a number of studies that we've been doing since last year. Last year, we announced the results of a survey. We had a deep sea research vessel working in our prospect area for 27 days. That's an image of the ROV submersible, which is descending down to the apex of the Exotica North hydrocarbon seeps. And in the background, you can see Lihir Island. So we're very close to land here, and it's quite an interesting story. Apart from improving our understanding of the shape and size and volumes of the deposit, we've done quite a bit of work to understand how we can commercialize this prospect. We've completed a gas to electricity study in cooperation with Newmont power engineers. We've been working with the industry to help us understand whether we could reach the field from an onshore drilling platform, and we've been looking at the concept of Papua New Guinea's first petrochemical industry, which would be uniquely placed at Lihir Island. So where we are, on the left-hand side, you can see our license areas in red. We're in the New Ireland Basin. Thanks, John, for showing where the basin was earlier. We have two active licenses, 625 and 352 in orange. We've also placed applications, and they're pending before the PAB in other areas based on our intellectual property we've generated in the area over 10 years of work. On the right-hand side is a new image. Many of you wouldn't have seen this before. We just produced this in the last several weeks. It is the culmination of work by Professor Chris Elders of Elders Geoscience in Perth. Chris Elders is the former Chevron Chair in Geophysics at Curtin University, now working as a private individual. And he's tied together 4 generations of seismic, over 350 line kilometers of marine seismic, all grounded on the basis of a fantastic survey that Searcher Seismic shot in 2017. So that's our baseline. And this is a 100-meter contour over the field, and the red stars represent where the seeps are that we have studied. We've sampled, collected them, photographed them, and made videos of them. There's four seeps that are known, and you can see the structure itself is quite significant. It's an anticlinal structure. It looks to be cut by a fault. It's closed in 3 directions, but we can't close it to the north, and so the opportunities to the north are quite tantalizing. Here's what the seep number 4 looks like. This is called the Basinl seep. It's natural gas. You can see the natural gas bubbling off the bottom of the ocean there. This is completely dark. This is 1,300 meters water depth. So all the life you see there are based on chemosynthetic life forms. The key, the factor that's feeding everything is our bacteria, which are eating the hydrocarbons. And so everything there is very happy to live in a hydrocarbon environment. This is what it looks like close up from one of those seeps. You can see the gas bubbling. That's 81% methane coming through there. You might be able to see a swirling, clear, immiscible liquid in the background. That's a condensate or a light crude oil. You can see some yellow on the samples nearby. That's native sulfur, which is precipitating from the waters as they cool. Just another quick look here. So you've probably, if you're a certain generation, you might have watched the Clampetts you would have heard of Texas tea. We call this New Ireland nectar. And it's currently supporting There's several of these Seeps operating over a 21-acre field at Karambousel. So what the work we've been doing in the last 12 months is to actually characterize these hydrocarbons as well as possible. Here's some sampling that was done of the gas seep. When the gas hits the funnel, it actually turns to methane clathrite or methane ice, but the gas still goes up into this titanium vessel, which has captured the gas and analyzed in Germany, independent lab. The analyses are here in yellow from 3 separate sites, averaged. You can see the methane, ethane, propane, and butane levels. And just as a comparison, the average amount of those molecules that go to China are on the right-hand side. So what the takeaway here is that this is a product which is actually directly exportable to the local market. The things that I would also point out are the low CO2 and H2S numbers. It's a sweet, looks to be sweet crude at this stage. These concentrations are in the lowest quartile of gas fields in the Asia-Pacific region. So it's a premium, low emissions product. The liquids themselves, they were analyzed using a different sampling device called a major fluid sampler. The nozzle was stuck as close into the vent site as possible. But there's always going to be seawater dilution. However, with modern mass spectrometry techniques, which have been done at Curtin University, we're actually able to quantify and qualify what the actual liquid is. It fluoresces a blue-white color. It's probably got an API between 50 and 60, it's a very light crude oil. It's like diesel. This is a gas chromatographic results here, basically showing the number of carbon atoms in each of the organic molecules in the liquid. And the key thing here is everything in green is typically generated by the maturation of coal or plant-rich sample sedimentary horizons. And the yellow component usually comes from marine algae, which grow in coral reef environments. So this is actually consistent with the model that we have for the area, that large volumes of New Ireland, which was a very large Miocene carbonate platform, topped with coal horizons, has actually collapsed into the basin and maturated with the elevated heat flow, which happened following volcanism since the Pliocene. Here's a cross-section through one of the seismic lines. What I've tried to do is treat the seeps like they were individual drills, wells, and you can see the top and the bottom of what the gas column might look like in the stratigraphy. Here we have, again, a 3-way closed anticline, 18 kilometers by 8 kilometers, over 600 meters of elevation difference, where we can actually see the hydrocarbons emanating from. So the minimum height of the gas column in this area looks to be 600 meters. In that case, such a buoyant force at such shallow levels of sedimentation that actually it's probably an overpressured reservoir, and that's what's causing the seepage in the first place. The probability estimates are quite large. It's shaping up to be a very sizable field. I've tried to put this into context for people who aren't quite experts in the field, but on the left-hand side, you can see the Exotica North gas prospect in comparison to the Hides gas field on the mainland. So we're in the ballpark. We're in the area where we're in a tier one prospect. That's the geology component. We've been focusing, of course, on commercialization, which will help us bring in partners. The first opportunity you can see here is the Newmont Lihir gold mine. Currently burns heavy fuel oil and diesel. You can see the heavy fuel oil exhaust. It's quite probably a high sulfur component with and that heavy fuel oil is imported from Malaysia, 5,000 kilometer transit. It's a very energy-hungry mine, 120 megawatts power required. The power infrastructure of the mine is aging. The first power plant was built over 30 years ago. So, but there's still a great opportunity here because the mine has depending on which numbers you look at, between a 16 and 26 year life ahead of it. And so we know from the information that energy is 20% of the cost of producing a bar of gold. So if you can reduce those costs, you've got a value proposition. So we commissioned a company in Perth, Resources WA, power engineers, to do an assessment. The reason why we went to them is because they had experience working with Newmont in various areas. They were familiar with this project in the Tanami Desert, where Newmont switched from burning diesel fuel at the Tanami gold mine to a gas-fired power plant, which involved building a 300-kilometer pipeline to the power plant. So the results of that study have been quite positive. Basically, the bottom line is that the development of a gas power station is viable, presenting both economic and environmental advantages for Newmont's operations on Lihir Island. And so some of the opportunities here for the mine are that we can build and operate a 140 megawatt power plant. They need extra capacity. The concept is they're moving away from diesel and into electric trucks and vehicles. And so that's a long life power requirement. We can save the mine, according to the modeling, over $1.6 billion for the next 15 years. The lower cost of production of gold, reducing on the order of $57 an ounce, could extend the mine life further because it can actually mine lower grade ore materials. We reduce the CO2 emissions by 32%, which is what Newmont stated in many public documents. And there will be provided domestic and secure supply of fuel from the local area. So opportunity for investors. This is people who are interested in the power area. That there's a significant revenue that could be generated just from the gas supply. You'll make 15% return on investment for the first 10 years, and then the field is, or sorry, then the plant is paid off, and you'll be in significant profit after that. And then there's also the opportunity to participate in the natural gas stripping opportunity. And so, okay, first of all, it's easy to build a power plant, but you need to get gas to it. So we've been looking at a number of different options. Obviously, bringing a drill ship in would be a great idea, but it's very expensive wells. We've been looking at this extended reach drilling concept. So on the upper left-hand side, that's a field, a 10-kilometer field offshore Argentina. In 1996, they were drilling from this cliff position into that offshore field. This is actually very common in industry right now. The bottom left graph shows all of the wells that have been extended reach drilling wells that have been drilled in the world. And you can see the Exotica North hydrocarbon target zone in the yellow box. They've been drilling to those depths and lengths away from the field for at least 20 years. So the concept is outlined here in the green. We'd want to be targeting, first of all, 6.8 kilometers away for the peak area of the anticline, and then extend them further out if that's positive. So we were able to get some support from the drilling industry, a company called Merlin Drilling in Aberdeen, Scotland, and Chris Fraser from High Arctic has given us some advice as well about what this might look like. So this is actual seismic line on that image there in green. So what we're showing is that it is possible, yes, we could just bring the drill ship in and plunk it down right through the top of the anticline. That would be the easiest thing, but that would be at least $100 million US. Is it possible to, first of all, start with an onshore well, which is a stratigraphic well, vertical well, to see if we can intercept any of the gas that's moving up dip from gas filling the anticline. If we can't do that, then we could deviate the well, a provisional well 2, to try to intercept it further out where we actually have good seismic coverage. And then obviously well 3 would be to tackle the field straight away. That is technically feasible. It's just, you need to have a lot of chutzpah to do it, but it's technically feasible to do. So we're looking at that as our initial strategy. So, but I mentioned earlier, what we don't know is how to close off the top of the field, the northern part of the field. There is a ring road around Lihir Island, and we've been talking to Vibrasize operators about bringing a couple of rigs onto the island, doing at least a 45-kilometer long survey along the ring road to close that off, see if we can find the strata, the gas-bearing strata underneath the island, and that would be the area we'd put the first well in. We'd also need to build a gas conditioning plant if we can land gas on the island. Gas conditioning plant estimates for that are $100 million, and then the power plant, the estimates for that are around $200 million US dollars for a 140 megawatt plant. So that's the strategy over the next 5 years. The other opportunity that we have that's unique to Lihir Island is the Newmont mine extracts oxygen from the atmosphere to react with the gold ores, which are sulfide rich. They basically need to oxidize or rust the sulfides to extract the gold. While they're extracting the oxygen from the atmosphere, they're actually extracting a lot of nitrogen. And if you can take nitrogen and mix it with methane and add electricity and heat, you can actually produce this white gold. It's known as urea. And so that would be a great opportunity for a first petrochemical facility in Papua New Guinea, and a product that's actually needed in the country. It's needed also in Australia. At the doorstep, there's a huge market for it there as well. So this is an example of a 3,900 metric ton per day urea plant in Brunei. These are quite common facilities built to support in the industry in Indonesia. And this is the sort of model that we're looking at if we can develop a cooperation agreement with Newmont around their nitrogen supply. But even with the mine requirements, power requirements, even with the fertilizer requirements, it's still, according to, if our numbers are in the right area, you'd still use less than 1% of the gas that's there. So we think there's a good argument here for thinking big about a standalone LNG plant on Lihir Island. And the advantages of this area are that it's a lot closer to the Japanese, Korean, and Chinese markets. And so we think we can actually produce a very low-cost gas supply to that Asian market. So our next strategies, this is next to the final slide. We're getting ready to do a Vibrasize survey on Lihir Island. That's for Exotica North. But to look at the possibility of firming up export volumes, we actually would like to do a more of a regional survey, a 3D survey, 1,500 square kilometers over what we call the Exotica play. There is a pinch-out structure that, like John mentioned earlier, which we call Exotica South, which is as big or bigger a structure than the Exotica North field. And so we're also looking to open up other opportunities through progressing the applications that we've got through the PAB. So as the Prime Minister said, the Prime Minister is aware of the project. We've got great support from the National Executive Council and from the local members of Parliament. Walter Schnabelt here is the member for Namatanai. We're hoping that we can bring on extra partners from Papua New Guinea. The Prime Minister said the other day during the speech, make sure you bring on the local people with you. We've been talking to local landowner companies. We're inviting them to join us, and we invite you to join us as well. Come and talk to us. Thank you very much.